LCS of three strings, difficulty medium. So if we're given three strings, S1, S2, S3, containing uppercase letters or lowercase letters or digits, well, uppercase, lowercase, and digits, find the length of the longest common subsequence in all three strings. An example, this is not the best example because it doesn't make clear what a subsequence is. It's not a substring. The subsequence, the characters don't have to be consecutive, contiguous. So this one, for example, the longest common subsequence is B1E. So here we have it as B1E here, here it's B1E here, and then B1E. That's the longest. The string size is up to 100. It's not much. Expected complexities. That's interesting. Okay. That is, okay, yeah. All right, time complexity is what you would expect. We need to look at every character in every string. The auxiliary space is not what you'd expect, but doable. Okay, company tags. D.E. Shaw likes this one. Topic tags, dynamic programming, and the other three are pretty obvious. All right. So normally, in a dynamic programming problem, you can have one-dimensional dynamic programming problems. You can have two-dimensional dynamic programming problems. The last problem that we did was unique paths through a grid. Because the grid, there's two variables, the row and column, that determine the state. And so depending on the number of variables that determine the state, determines the dimension typically of your dynamic programming array. So in that case, we did it with an array of 2 dimensions. Okay, now if the length of any of these strings, this is a edge case, if the length of any of these strings is 0, then there is no longest common subsequence, or rather, I should say the length of it would be 0. Let's talk about the recursive relation here. Okay, so we get 3 strings. Now, if S1, and let's use I, J, and K. I didn't use I, J, and K, but well, for the sake of talking about it, no, I did use I, J, and K. I'm sorry. I'm looking at the length here. Let's use I, J, and K as indexes into S1, S2, S3. So at any point, if we start I, J, and K at 1 and then iterate through the length of the strings, at any point, S1 at I minus 1, and S2 at J minus 1, and S3 at K minus 1, if those are all equal, then we can add 1 to our best previous match, which would be at the data processing array at I minus 1, J minus 1, K minus 1. If they don't match, then we just continue to use the maximum LCS length that we have found so far by excluding the last character from one of the 3 strings. All right. Now, this thing about the space here, n2 times n3. So they want it to be done with a two-dimensional dynamic programming array, which we can do. This is not so easy to visualize with a 3D array, but So if we think about the array from the previous problem, which was paths through a grid, and the basic idea was you can initialize the top left corner of that grid to 1, and then iterate through the grid row by row, cell by cell, and the number of unique paths to any other set of coordinates would be this, and you're only allowed to move to the right or down. So it would be the sum of the value of the cell above the current cell and the cell to the left of the current cell. The thing is, as we go through this array row by row, we really don't care about any of the rows other than the row above the current row. That is, once we've processed a row, we don't care about it anymore. So we don't really need to keep it around. We can have for the rows, we can have like a rolling array. Now, as I said, the value of any row is the sum of the row above, and the sum of any cell is the sum of the cell above and the cell to the left. So if we just roll the row down into the next row, that gives us the cell above, and then we just add the cells to, the cells on the left. Okay. So we can do the same thing here, not quite as easily. I mean, we can use a 2D array. Think about how I want to say this. All right, well, let's say it like this. Let me scoot this over a little bit. Let me pull this so hopefully we can see all of it. I can't pull it any more than that. That's not good. In that case, maybe what I want to do is, what would happen if I split it here? Is that visible underneath everything? It is. Okay, and then we'll actually do the same thing here. That should allow us to see everything. Yes. Okay. We're going to use two-dimensional arrays. We'll call them DP1, we'll call them DP2. And again, we're going to have like a rolling update. So through each iteration, and we are going to have, a 3-level nested loop. In each iteration, the DP2 array is going to be, how do I want to say this? The DP2 array is going to be updated based on DP1. And then we're going to copy DP2 to DP1 after each iteration. And we're going to reinitialize DP2. So again, through each iteration, DP2 will be updated based on DP1. And then we will copy DP2 to DP1. That is happening down here. We swap them. We do the swap, and then we reinitialize DP2. That is, we go through each iteration. DP2, we initialize it to 0 because we don't know what's going to happen in this iteration. We know what we've done so far. That's stored in DP1, and that is where we will return the value. But we're going to do what we said we were going to do before, which is at each iteration, if the character in S1 matches the character in S2, the character in S2 matches the character in S3, if they all match, then we can just add 1 to the previous best. On the other hand, if they don't match, we're going to keep the best thing we have so far, at each point excluding one of excluding the most recent character from one of the strings. So in this case, we're excluding the character from a string from S1. In this case, we're excluding from S2. In this case, we're excluding from S3. All right. This is, yeah, again, this is a pretty common, well, it's a common question, a longest common subsequence. It's not common that you would be asked this question with more than 2 strings, and it's not common that anyone would insist that you space optimize it. In other words, with 2 strings, you would typically do it with a 2D array. Now, someone could say, just do it with a 1D array, all right? And you would have to use this rolling array technique. It's not common that someone would say, do it with 3 strings, and also space optimize it so that you're only using a 2D array, right? Now, I have written this code, although I haven't actually run it yet. Well, let's do the. I did compile it, and that worked. I'm going to click the submit button, which is out of the frame at the moment, but I want to be able to see the results. And we're getting close. Whoa, whoa, whoa. Oh, all right, there you go. I earned a geek bit. I wonder what I can redeem that for. Okay, attempts. Why does it say 2 attempts? Maybe the compile and run counts as an attempt, but okay. Let's see. All right, so that's it. Please like, subscribe, and I'll see you next time.